Alright, number one, the key word in this problem is circumcenter. So D is the circumcenter of triangle ABC. Segment ED is 9, and that's labeled right here. Segment EC is 12, and that's labeled right here. So circumcenter is at D. And if you take any triangle, so look at segment AC. From A to C, if you put a perpendicular bisector on here, which is this line right here, and if you take AB and do a perpendicular bisector there, all of your perpendicular bisectors are going to cross. They're going to cross that point D. Now what's sweet about D is equidistant to each of the vertices. So the distance from D to A, D to B, and D to C are all equal. So the question wants me to find the length from B to D. That's this right here. But I know that B to D is going to be the same as D to A and D to C. So if I can find one of them, I found all three. And I am going to find this one right here, D to C. Because look, if I cut just this triangle out, there's a 90 degree. This leg is 9 and this leg is 12. And I know that in any 90 degree triangle, if I've got two of the three sides, I can use Pythagorean theorem to find the third side. So Pythagorean theorem, a squared plus b squared c squared. And in this triangle, C is going to be this guy right here. So I'm going to go 9 squared plus 12 squared equals c squared. 81 plus 144 equals c squared. And if I add those, that's going to give me, what is it, 225 equals c squared. And then do the square root of both. You're going to end up with c equals 15. So I know that from D to C is 15. So that means D to B is 15. And A to D. These all three are 15. Alright. So the second question, what is the length of segment AE? Okay, that's kind of a easy one. A to E is going to be 12 because E to C is 12, and I know that AE and EC are congruent. Alright, that's problem number one. Number two, okay, the key word right here is perpendicular bisector. Segment CD is a perpendicular bisector of triangle ABC. So this guy right here, CD is a perpendicular bisector. That means this. That means AD is equal to DB. And that also means that this right here, from C to A is equal to C to B. So the distance from C to A is equal to the distance from C to B because it's right on the perpendicular bisector. Alright, so they want to know what is the length of AC. So they want this right here. And they've given us algebraically the AC equals 2x plus 12. So you're going to have to use algebra. You're going to have to set AC, which is 2x plus 12, equal to CB, which is 6x minus 10. Now, if I solve the algebra, I can find x. Let's see if we can figure out the value of x. Okay, I'm going to move number one. I'm going to minus 2x here, minus 2x there. So that gives me 12 equals 4x minus 10. Whoops, 10. Okay, now I'm going to plus 10, plus 10, and it gives me this. 32 equals 4x. Divide by 4, divide by 4. I just found x. X is equal to 8. Okay, so now if I want to find the distance from A to C, I'm going to take 8 and I'm going to plug it in right here. So AC says to do 2 times x. So 2 times 8 is going to be 16, and then add 2, 17, 18. Okay, the segment of BD, well, BD is going to be whatever AD is, and if AD is equal to 5 times x, then it's going to be 5 times 8, which is going to give me 40. Alright, that's number 2. Let's do 3. Let's do a proof. 3 says, using the same triangle for number 2, here's what we want to prove. We want to prove that triangle ADC is congruent to triangle BDC by our congruency theorems and postulates. That's like angle, side, 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 hypotenuse, leg, those. And let me erase this. Here's what I'm going to use. Whoops. Alright. So, here's what we know. I know, let me maybe copy this right here. I'm going to call this A, D, B, and C. I know that AD is congruent to DB because it's a perpendicular bisector, so it bisects AB. I know DC is congruent to itself because of a reflexive property, and here's what I know. I know that AC is congruent to CB because C is equidistant to A and B because it's on the perpendicular bisector. So I have a pair of sides, 2 pair of sides, 3 pair of sides. So I'm going to use this. Side, side, side. So here we go. Statement number 1. Segment AD is congruent to segment, what do I got here? Here's what I'm going to use. I'm going to use AD is congruent to BD. The reason for that is D is perpendicular bisector of segment AB. Okay, reason number 2, I'm going to do this. I'm going to say DC is congruent, so I did this time DC, so I'm going to go DC. DC is congruent to itself because of the reflexive property. And the last, let's go from A to C. So segment AC is congruent, and because I went A to C, I'm going to go B to C. So AC is congruent to BC because C is equidistant to both A and B because it's on, well, it's on the perpendicular bisector of AB. So I've proven it. Side, a pair of sides, a pair of sides. So my final statement is this. Triangle ADC is indeed congruent to triangle BDC, and my reason is because of the side, side, side postulate. Okay, let's look at number 4. Number 4, centroid. Alright, centroid is the key vocab right there. G is the centroid of triangle ABC. Alright, so right here, triangle ABC, the centroid comes from the medians. The median does this. So the median goes from a vertex, so from A, and it cuts the opposite side in half. So I know that BE is congruent to EC. So this vertex B, if you draw a line from the vertex to the opposite side, it's going to cut it in half. So I know that AF is congruent to FC, and the last median C hits the opposite side AB, and I know that this side is congruent to this side. So look right here. AC from A to C is 30. That means this half is 15 and this half is 15. And let's see what else we've got. I think it's labeled. Segment BG is 12. So from B to G is 12. And from G to E is 9. G to E is 9. And then AC is 30. Okay, we've got it all. So 3 questions. Question number 1. What is the length of segment GA? So from G to A, what is the value? Now here's what's sweet about the centroid. The centroid is exactly 2/3 of the way through the median. So look at my line right here. My entire line from A to E, and G is not halfway, but G is 2/3. And from G to E is 9, so that I know there's gonna be a 9 here and a 9 here. So if I divide this line into 3 parts, each part is going to be 9. So the distance from A to G is going to be 18. So I'm going to label that in 18. And what is the length of F to G? Okay, let me draw that line too. F to G, here's B. Here is G, and here is F. Okay, from B to G is 12, and that's the bigger part of it. So I know how big is each chunk. If from B to G is 12, I know that from G to F has got to be 6. And I just divided 12 by 2 and got 6. So that means each segment is going to be 6. So if I draw a line again, here we go. This chunk's going to be 6, this chunk's going to be 6, and this is 6. So 2 6s, that's giving me the 12. Alright, so I just got F to G is 6. And then the last question, what's the perimeter of AGF? AGF is this triangle right here, from here to here to here. And the perimeter, I add up each side, 15 plus 18 plus 6. And what does that give me? 39. Okay, number 5. Let's look at number 5. Segment FE is equal to 8. Segment AB is equal to 5x plus 1. That's this right here. And then, what is the value of x? Okay, it doesn't give you any key words, but the key words are actually these marks right here. These congruence marks. So E is actually a midpoint of BC, F is a midpoint of AC, and D is a midpoint of AB. So these are exactly the midpoints. Now if you connect your midpoints, you get a mid-segment, and there's something pretty sweet about a mid-segment. Okay, this mid-segment right here, from F to E is 8, and I know there's a mid-segment theorem that says this segment FE is exactly half of the opposite side. So if this F to E is 8, I know this. A to B equals 16. Because 8 is exactly half of 16. So now if AB is 16, AB is also 5x plus 1. So 5x plus 1 is equal to 16. Now I'm just going to do the algebra. Minus 1, minus 1. 5x equals 15. Divide by 5, divide by 5. I just solve for x. X is equal to 3. Alright, so now question 2. What is the measure of angle EFC? Angle EFC is this guy right here. Right here. They want to know the angle of that. Okay, the mid-segment theorem says this. This line is going to be parallel to this line. So here's what we got. Without all the triangles, I got 2 parallel lines. And my transversals right here. So if this guy is 45 degrees, which is that, then this is also 45 degrees because they are corresponding angles. So this is 45 degrees. And then what is the measure of EFA? Oh, that's this one. EFA, how big is this guy right here? Or this one. Well, I know that this is a linear pair. They're on a straight line. So if this is 45, this is going to be 180 minus 45. Which is going to be, what's 180 minus 45? So 135?